In this presentation, we are going to take a look at C#'s overriding and virtual member capabilities. As you are probably already aware, you can override the toString method in any of your custom classes or structs to display or create a string representation of an object's state data. For this to work, the toString member must be marked as virtual or abstract in its base class. We're not going to look at abstract right this minute. Let's just focus on virtual members. Virtual members are simply members of a class that can be overridden or changed in a derivative class. We're going to start by creating a person class with some common attributes for this data type. So I'll create an int called ID, and we'll give it get and set property accessors mutators. Then we will also add a public string called last name and another called first name, and one more called date of birth, and this will be a date time, and we'll abbreviate it DOB. Right now these are all auto properties. We may decide to change them later based on specific business requirements, but for right now we can leave them just as they are. What we can do now is override toString and have it return a formatted string that contains this state information. So we'll format ID, we'll assume Social Security number format, and then last name, and we'll format that left justified 15 characters. We'll do 15 characters for first name as well. And then date of birth, we will give this particular date time format. Now, when we create an object of the person type, anytime we access the toString member, it will format its data in this manner. Let's go ahead and add a constructor as well by highlighting these properties, selecting quick actions, and generating constructor. And I'll put the constructor after the properties. I prefer that layout. Go back to program. Let's create a person. And we'll give it ID values, last name, first name, and we'll do a date time parse. And let's fix this M here. Now if we do a console write line of P, we should see that person data formatted as a string given the format specifications we supplied in the toString member. And sure enough, we see the data. Let's go back to person and let's take a look at the definition of the toString member of object. The easiest way to do this is to somehow reference that member in your code and hitting F12. You can also go through the object browser, but this is typically the quickest way to get there. And as you'll notice in the disassembly of the object class, it's not a true disassembly, it's just the metadata, you will see that several of the members are marked with this virtual keyword. That indicates that to any derivative of the object class, we are able to change the definition of how toString works, also how get hash code or the equals method works. Not all members are marked virtual, therefore you cannot override this getType method. I can show you that by attempting to do it. First, if I type override, it doesn't show up in the list. So I could try to copy its signature like this, and then return null, just to have it return something. But the problem here is it says person.getType hides inherited member object.getType. Use the new keyword if hiding was intended. Okay, so it's not necessarily an error, but right now it is indicating that this is going to hide the getType member of the base class because it is not intended to be overridden. As a matter of fact, I cannot use override here because that is not an overridable method. So what it's asking us to do is to supply this new keyword that allows us to define the getType method in this class, but it is not the same getType method. This is one specific to person and is only accessible via a person object, and it is not going to participate in the vtable lookups that virtual members will. What's so special about these vtable lookups? Well, when you access a member of an object that is virtual, it may have also been overridden. This is still a virtual member because that's the original definition in object. Anytime you create a derivative and override it as well, this entry in the method lookup table, or the vtable, will point to the same address offset as the one defined in object. So they are basically, this toString member and this toString member, they are going to point to the same offset. So when you have an object of type person, even if it is in an object variable, it will call the method at the specific offset for that object, not object itself, as in the type name, an object being a variable. So if we do that, let's go back to, I'm going to comment this out just so we don't have any interference. I'm going to go back to the program class, and then we are going to stick P into this object called O1. And if we again do the right line, but this time pass it O1, you'll see it still prints all of the person data correctly. If it was actually objects toString method, then what would happen is we would see overrides and virtual members dot person, because that's the class name. If I change this override to new, and I can get rid of this base.toString call now. We just use that to look up the method in the metadata. We change it to new. It is no longer overriding toString. And let's rerun the code. Now, as you can see, both times it prints the namespace .class because there is no overridden version of toString in person. So the vtable lookup is going to return the toString member of object. By changing this back to override, oh, we don't need that back. Let's change this right here. Back to override. Now we will once again show the toString member, or execute the toString member of person, which gives us the overridden display or output from the toString method. We can continue this by creating a new class. This time we'll call it student. And student is going to derive from person. The first thing we want to do in the student class is to create additional attributes like we did in person, and then create an appropriate constructor for it. So for a student, maybe we'll need something like a GPA to indicate their grade point average. And we will also possibly need a list of classes that this person has taken. I'll define what that class is going to look like. As you can see here, we have a generic list, but we didn't supply a data type in here. Now we can pick just a string, so you can identify just things like the name of the class, but I'd like to extend this definition a little bit. So before we finish this definition, let's create yet one more class. We'll call this class. Now, this may look illegal because we have the word class twice here, but because capital C is not the same as lowercase c, these are distinct names and therefore they don't conflict with each other. The first member we are going to add will be a string called ID, which will correspond to the class ID or the course ID. Then we can have another property called description, which is the course description. And then we will add a float called units that indicates the number of units for this particular class. Once again, we need a constructor, so I'll take the shortcut. And I'll fix this in person as well. I don't like how it changed the casing of ID there. And now let's override toString so we can create a string representation for this object. And we'll do the course ID first. We'll assume up to 10 characters. Then the description, we'll give that 25 characters. And then the units, we'll assume they can do up to a quarter unit. If it was only going to be split in halves, we could, of course, do it this way as well. But we'll assume quarter units somehow could be possible. So we have our class created. Let's go back to student, and we will make the classes collection a list of class objects. Now we need a constructor for this class. That's why we're getting the red underline here, because there is no appropriate base class constructor to call. And then we are going to copy this here. As a matter of fact, I said I would fix this. I don't really like how it does the little I, big D. I'm going to fix that in person right now as well. Just a little pet peeve I have. This is going to be the student constructor, not the person constructor. And we have to make sure that we call base, passing it in these four values. I'm going to copy them as they are and remove all of the data types. Then we are going to create an additional float here for GPA, and that is what we're going to set inside this constructor, because the base class constructor will take care of these four values. I think I'll fix DOB as well. Again, pet peeve. I'll change it in person. Now notice here, this constructor is not accepting a value for the classes collection. So what I need to do here is I like to make sure at least it's legal once the constructor was called. Then I will create another constructor that accepts a list of class objects as one of its parameters. Then we can do this. Now we could be really tricky here if you'd like, and then we could say instead of calling base, we can say call this, supplying it GPA. Then I can remove this call. Now what happens is when this constructor is called, it will chain over to the first constructor, which will set the GPA, and then it will set classes to a new list of class objects, and then we immediately after that is done, we set it to what was passed in. Is this any better or any worse? It depends. If you like to consolidate all of your logic into a single method, this is probably the best approach to take. Or create another internal or private method that is called init or initialize, where you pass all of the possible input parameters and handle all of the logic in that method instead. Neither approach is really better than the other. However, you will see this one commonly employed because it minimizes the amount of code repetition that you may have. Now, another approach would be instead of doing it this way, where it sets classes to a new collection and then we override it by changing it to what was passed in, we could have this as the primary constructor, which is called by the other constructor as well. So let's look at how that would play out. We would still have the need to call the base class constructor as such, but now instead of this one calling the base class constructor, we'll have it call this constructor, passing in GPA, and then a new list of classes for that last parameter, and then GPA will be set here. Now we don't have a superfluous creation of the list of class objects call like we did previously, because this one will only be called when it is intended to be a blank list. When we actually pass it in as part of the constructor parameters, we do a simple assignment. So in this case, this new list of class objects maps to this class's parameter of this constructor. We're not done quite yet though. Notice when we created the person object, we are assuming that the ID is some kind of social security number. Most schools do not use social security numbers for the student IDs anymore. They have their own format. That way they are not leaking potentially sensitive information if they include that number in correspondence. So what we need to do possibly in this class is change how that ID works. Let's go back to person and flesh this out a little more. Notice here it is a auto property, so we don't have a backing variable, and that also prevents us from having any type of data checking because we don't have formal get and set accessors. So what we need to do is create, I'm going to make it protected int ID as such, and now I am going to change this property definition to be a fully specified traditional property. So that means I'm going to need a get block and a set block. The get block is going to return ID, and the set block is going to set ID. We also, now that we have the capability of doing so, probably wish to make sure that this value being passed in is within some legal range. So we will add an if statement and say if value is greater than 0 and value is less than or equal to this value, then we allow for the assignment. That prevents us from creating an ID that is out of range, especially because we're assuming that it will format correctly with 9 digits. That's why it must be less than or equal to this particular value. So else, throw new argument out of range exception. And we'll just give it the ID. You know, we'll use this version of the call. Must be between 0 and 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So this works to validate the incoming ID. And notice we didn't have to do a whole bunch of reworking of the class to support this property. Notice the ID is still recognized here as a property. It's also recognized here. But that's why it's usually beneficial to start with a property, even if it's an auto property, and then change it to a formal or fully specified property later if necessary. You may also be wondering why I picked protected instead of private for this particular underscore ID variable. Protected is used to allow access to any derivatives, but to everything else, it's private. So if it was private, only person could access underscore ID. However, since it's protected, I can access that directly from student as well. As you'll see here, ID shows up as a protected value, but I can access it since this is a direct derivative. One last thing. The reason I went through all the trouble of making this a fully specified property as such is to make it so the student class can change the behavior of ID based on its requirements. Right now, we are assuming that this is a valid range for the ID for both a person object and a student object. But our school may have a completely different definition for how big a student ID could be. In that case, we need to be able to override ID. But we cannot override ID at this moment because if we go back into the student class and type in override, the only thing that's going to show up are the same 3 things that were overridable from object. And that is because to be overridable, you must mark it as either abstract or virtual. In this case, we are going to say virtual because our person class provides logic for that value. It would be only legal to make it abstract if we wanted to supply the contract to say we have an ID property, but we don't have the definition of what it actually does at this level. We do have functionality here, so we have to mark it as virtual. Now if I go back to student and type in override once again, you will see ID shows up as a potential candidate. Right now, it is assuming that it's going to retain the base functionality by returning base.id or setting base ID equal to the value. The get is actually fine the way it's written. We don't have to change that right now because we are assuming we're still going to use an int for the ID. And that brings up another point. Let's say the student ID required some alphabetic characters like A to be embedded in the ID. Then this procedure would not work because when you override, you can't change the data type. So if it's not a string in the base class, you can't make it a string in the derived class. We're going to assume in our example here that we're not going to have alphanumeric characters, just numeric values. So we are okay to override int. But instead of allowing values all the way to 9 nines, we are going to limit it to maybe 7. And we also still want to make sure it is greater than 0. Now, we have a choice here. I can assign directly to ID, underscore ID as such, because I marked it as protected in the base class, which was person. Or I could make use of the property much like I did in the getAccessor. This is the person's ID property. So I have a choice. I can do it either way. However, because there is logic contained within the person's set mutator, my logic I defined in student's mutator may run afoul of that logic. It doesn't because we are restricting it to 7 nines, which definitely falls within the same range. But that is something else that you have to watch out for. We're going to assume we don't know what the base class's logic requires. So we will have our own check, and we are going to assign directly to this underscore ID value. I will fix this message so it knows that the ID has a more restrictive range for this particular derivative. Now let's take a look at overriding toString. Because we have additional values such as the GPA and classes, we are going to change how this toString works for this student class. The biggest change is going to be, first of all, we have to modify how the ID is going to look because it's not going to be in Social Security format. So let's start with this. And instead of issuing a return formatting these 4 values, we are going to create a string builder because we have several things we actually need to do. So we'll create a new string builder, and then we will append the master student record, so to speak, to that string builder. We can do that. I'll get rid of the return for now. We can say sb.append, and we can use append format if we wish to use traditional string formatting. But if you prefer string interpolation, then by all means do it thusly. And then we'll return sb.toString. So we have the student's ID, which we're going to change the format. Let's make sure the format looks something like this, where maybe the first 2 digits corresponds to the year of enrollment for the student or their first class, and then this would be a sequential student number that follows it. I'm just pulling something out of thin air. That sounds like a good format though. So we should have 1, 2, and then 5 digits here, right? Because we allow 7 digits, so this is 7 digits. We'll still do last name and first name appropriately, and then we are going to add their GPA. And we will specify the GPA as 3 decimal places. Now, you may notice that on some of these values, when we format them, we don't supply the spacing value like we do with last name and first name. And that's because the way it's formatted, we are specifying this is always going to be 8 characters. We are specifying this is going to be always these 10 characters, and this is always going to be 5. So unless we needed to add additional spacing, it would be a superfluous value. So if we actually said GPA colon, and then before that we did comma 6, so right justified 6 characters, it's not going to do anything except for add one extra space in front of the GPA. If we made it a 5, this accomplishes absolutely nothing. So unless you absolutely need the spacing in there, you can leave it off. However, we're still not done with this toString method because we have not accounted for the classes collection. Let's go ahead and change this append to an append line, which will add a carriage return line feed pair to the end of this formatted string when it adds it to the string builder. Then what we can do is say append line, another one, and put classes like this, and then we can iterate through the collection of classes and add it underneath this particular line of text. First though, let's check to see if they actually have any classes. So if classes.count is greater than 0, then we'll do one thing, else we'll do something else. Here we can say sb.append line, no classes on record. Otherwise, what we can do is say for each class C in classes, and instead of appending no classes on record, we could use string interpolation, put a couple spaces in front, and then just place C there. Now what will happen is it'll call the C toString member, which is classes toString. Since I don't have spaces at the beginning of this toString, and it doesn't make sense to put it here because we don't know the context in which this class is going to be used. So when it's used within the context of a student object, that's when we embed those extra spaces in front to indent it. That way, if we have multiple of these records, they will line up nicely. Okay, let's see if we can exercise our new student class. Let's go ahead and create student1 is equal to new student, and I have the two constructors, one with or without the classes collection. We'll supply an ID, and remember we can allow up to 7 digits. The last name, we'll pick Williams, first name John, date of birth, datetime.parse, and here we'll supply 1988-09-12, and then we need a GPA, and John is a pretty good student. And remember, if it's a float, we have to supply an F here, because otherwise the compiler will view it as a double. It doesn't matter if it's a lowercase or uppercase F. Either one is a sufficient or an appropriate suffix for a float literal. Then we can create another student, and we'll say student2. Oh, didn't I say the first 2 digits was going to be the year of enrollment? So this person enrolled in 2012, I guess. So let's change this one to 10. 1, 2, 3, 4, 5. And Smith, Jane, and we'll say it's the same Jane that we had up there. And I'll say Jane is a better student than John. And then I can either use the constructor call that accepts the collection of classes, or I can add it after the fact as such and say add and then new class, and we'll give it a string ID of CSIS-123. The description is compiler theory. Actually, it'd probably be a 400 level class, wouldn't it? And then the units will be 3 units. And then we can add several more classes. We'll say 377 operating systems, and then maybe 401 and algorithms. That has a lab, so it'll be a 4-unit class. Okay, so now this student will have 3 classes associated with her. Let's create a list of student objects. Call it students equals new list of students. And then we can use the initializer syntax to provide S1 and S2 as such. And we could have done the same thing when adding the classes to S2. For each student S in student, it was actually students with a lowercase s, console write line s. Let's go ahead and comment that chunk of code out so we don't have too much noise on the screen. And when it runs, you will see the first student's information. So John has no classes on record. And then Jane has the following 3 classes. Now clearly, for John to have a GPA so high, he would have had to take at least a couple classes, maybe 1 or 2. Most of the time you can't earn a 3.7 from one class. But besides the fact that the data is a little wonky, it demonstrates how this works. And because the toString member of student has a different output than that of person, as you can see here, we are able to actually change this list of students from a list of student type to a list of person type. And then we can say for each person P in students, then write P. Even though every one of these objects is technically a person because it is a direct ancestor of student, it is still going to print the values correctly because the toString members are properly overridden in the derived class. So you don't have to worry about what the data type is. We could have even made this object because that is also in the same ancestry because object is the root. So because of the V table, it knows that, well, this is a student object. I know to call student's version of toString. Let's go ahead and change all of these back to the intended data type. So it is a list of student, because that's really what we intended to do. But let's also take a look at this person class, and let's add something to it that we intend to override, but we can't, so we're going to have to hide it instead. Right now we have a last name and a first name. We have a date of birth. The one thing we don't have is a gender. So let's go ahead and define a gender enum. And sometimes I like to put them in its own file for all of my enums in a project so they're all consolidated. Sometimes it makes sense to define it within a class itself if that's the only place it's going to be used. Or you can define it in the same file as the class it's going to be used, such as this, public enum genders. So this is perfectly legitimate as well. So we know that we may want to supply, let's do it alphabetically, so female, oh, better yet, undefined or unknown equals 0, female, and male. And then we can define our value as such. It'll be a property. And life is pretty much good. We need to probably also add it as a parameter to our constructor and then set it thusly. We will also have to change student because, as you can see, the base class does not support a call without it to its constructor. So we'll stick it right here in the same place, genders. And we'll put that here. We'll have the same issue here as well. So let's go ahead and fix it. So there's a little bit of work, but it's not too bad to retrofit a class as such. Oh, do we have something backwards? Should be after date of birth. Oh, I put it in the wrong place. It should be after date of birth, but before GPA. Okay, that looks better. Let's go back to person. We should probably fix the toString member. And let's say unknown, or is it undefined? What did I call it? Undefined. You know what? Let's change it to unknown, just because it's a little smaller, and that'll be 7 total characters. So we'll define it as left justified 7 characters. Then the last place we have to fix things is within the program class, because we don't specify gender anywhere here. So we'll specify genders. This is a male. And gender's female. Okay, and let's take a look at person. So that prints everything out correctly. Student. Notice here we don't have gender showing up anywhere. We can add it the same way we did it for person. Let's go back to program. Let's see if this builds, make sure we have everything done, and then we'll get to the whole process of hiding it. Okay, so we have that set up correctly. Looks good. Now, let's go back to this student class. Let's try to make the assumption here that the gender of the student can never be unknown. For some reason, they have the requirement it has to be either male or female. Well, the issue we have here is that in person, because it's an auto property, we have no such capability to lock it to just male or female. So our issue is we would normally override it at this level. So we could override, and then we would supply the gender property here. But it's not in the list because we did not mark gender as virtual. So that right there prevents us from doing a proper overriding of this value. So the only choice we have is to make it a hidden property or a hiding property. So it shadows or hides the base class member of the same name. So we will have to create a new property called gender. And then we would have to supply the functionality we require here for this particular class. It doesn't mean we can't utilize the base version of gender. For instance, we could have get here and it would return base.gender. But when we set it, we are going to make sure that it's either male or female. So if value equals genders.male or value equals genders.female. Try not to read anything into the order I did those in. Then we can say base.gender is equal to value. Otherwise, we need an else. We'll throw, we'll just say, call this an invalid argument, or argument invalid. That's the one I think I want. Or argument exception. That's fine. Gender. Let's see. Oh, this one's backwards. The parameter name comes after the description. It's funny how they did that. Now, oh, we need to get rid of this comma. So gender must be, let's say, female or male. So we have not truly overridden the gender property. However, when we call gender from this toString, it will access this accessor because it is the most locally defined version of that gender. As a matter of fact, if I select it and go to F12, you can see it takes me to this gender property. I'm still using the base class gender to store the value, so that's still available, or I could have defined my own backing variable within this class as well. So what does this actually do for my code? Let's go back here to the program class and let's uncomment this person. We need to add a gender value here. We can say unknown. But let's try to do the same thing with this unknown for this student. Now, you might think right now this is going to cause a failure because we don't allow unknown inside of that student. But you'll be surprised at the results. Let's run it. We'll step in, and you'll notice here when we call this constructor, it redirects to the other constructor. And notice here, we don't access gender anywhere from the student constructor itself. Where is gender accessed? Well, we pass it as a value to the base class. So we step into that, and then we step over each of these properties until we get to gender. Now watch what happens when I hit F11 to step into gender. It takes me to the base class gender property, not the derived one. Now this is different than how a virtual member that's overridden would work, because if I call gender here, and if it was truly overridden, then it would redirect to the student's version of gender as such. But because it is a new property, not an overridden property, this class person has no idea it exists. The V table does not exist for gender, so it doesn't even bother to look to see if the student class has it. So now it's going to allow gender to be set, and when we just let the code finish executing, you will in fact see that John Williams is also unknown. So we didn't get any errors flagged. So the only way to fix that problem would be to attempt to assign gender at this level. Now when this constructor is run, I'll put a breakpoint there so we can get to that level. So we attempt to construct student 1. We are in this constructor. It's already called the base class constructor, so the base gender is already set to unknown. How do I know? If I expand this, you'll see gender is already unknown. Now try to make an assignment to this gender. Notice it steps into students gender property, and now it will throw the argument exception, which will cause our code to enter break mode because it's an unhandled exception. So as you can see, things start to get really messy when we start dealing with this new operator and hiding members. That's why if you're going to do overriding, do it the right way and make sure that the base class members are marked virtual. So let's go back and change the person class to have a virtual gender member. We'll go back to student. We'll get rid of new and make it override. See, now we're overriding gender. We don't really have to change any of the code in here because we were dealing with the base gender properties anyway. And we can get rid of this superfluous call to gender equals gender at this level. Let's rerun the code, but this time when we get to the persons constructor, I'm going to put a breakpoint here when it tries to assign a value to gender. See, now when we are in person's gender constructor, this is for the first person, so we can safely execute that. Now we're at student S1. If we hit F5, it'll take us again to the person's constructor. This is for S1 this time. So gender is, in fact, unknown. When we step into this method, however, it will not step into the person's gender property. Notice it took us right to student, the override of it, because now it is a true overridden member, and the vtable lookup says even though in the person class we have a perfectly viable gender property at this level, we are really dealing with a student object now. So therefore, we will call student's version of gender to do the assignment. And now you can see we get the same exception thrown. So this really demonstrates the power of using virtual members and overriding so you can leverage the base class functionality, but at will change how the functionality works. So you can add additional business logic, you can add additional restrictions like we did with the ID member and the gender member. So we better make sure we change this back to something legitimate, otherwise we'll keep getting that unhandled exception.